Section 14.2 is on division and reciprocals. So two expressions are reciprocals of each other if their product is 1. The reciprocal of a rational expression is found by interchanging the numerator and the denominator. So all that means is we're going to flip the numerator and the denominator, or flip the fraction. So the reciprocal of 2/5 is just going to be 5/2. The reciprocal of 2x squared minus 3 over x plus 4 is just x plus 4 all over 2x squared minus 3. And this last one's a little bit more tricky. If there is no distinct denominator, remember that we can always write these things with a denominator of 1. And so the reciprocal would just be 1 over x plus 2. And so when we talk about dividing rational expressions, this is just fancy multiplication. So we're going to implement the keep, change, flip. And so we keep the first fraction, we change the division side to multiplication, and then we flip the second fraction, or we find its reciprocal. So a over b divided by c over d becomes a over b times d over c. Then you'll factor and simplify if possible. So for the first one, we have 2 over x divided by 3 over x. So you're going to keep the first fraction just the same, 2 over x, and then change division to multiplication, and we flip or find the reciprocal of the second one, which is just x over 3. Now from here we want to simplify. So we can cross multiply and get rid of the x's, and that's about it. And so what we're left with is just 2 over 3. For the second one, we have x plus 1 over x plus 2 divided by x minus 1 over x plus 3. So we can't simplify anything where we're at, like factoring or simplifying across. So we are just going to do keep, change, flip. So we have x plus 1 over x plus 2. Then we change division to multiplication, and we flip the second one, so we get x plus 3 over x minus 1. From here you want to see if you can cross multiply and simplify, which we can't, and so we just multiply across the top and bottom. So we have x plus 1 times x plus 3 all over x plus 2 times x minus 1. For part C, we can do some simplification first. And so I'm going to factor whatever I can on the top and bottom. The top of the first fraction is already pretty simplified, but the bottom can be factored, and that's a difference of squares, as x plus 1, x minus 1. I will do the keep, change, flip after I'm done factoring the top and bottom. And so the x plus 1 on the second fraction, again, is going to stay the same, but the denominator can be factored as x minus 1 times x minus 1. And so now that I'm completely factored, I'm going to use keep, change, flip. So our first fraction is going to stay exactly the same way. We're going to change division to multiplication, and then we're going to flip the second fraction. So we got x minus 1 all over x plus 1. So now let's look on top and bottom of each fraction. So in the first fraction we can cancel x plus 1 and x plus 1. And we can't cancel anything in the second fraction, but we can do some cross multiplication, and the x minus 1 and the x minus 1 are going to cancel. And so what has happened is our first fraction has completely canceled, and what we're left with is x minus 1 over x plus 1. And for the last one, we want to approach this one very similarly to the one previous. Let's go ahead and factor the tops and bottoms. So the first one can factor is x minus 3 and x plus 1. And then on the bottom, that's again a difference of squares. So that's going to factor as x minus 2 and x plus 2. We can't really factor or simplify the second one, so I'm going to go straight to keep, change, flip. So we're going to change that division to multiplication and flip the second fraction. And then let's see what we can cancel. So I can't cancel anything on top and bottom, but I do have one little cross multiplication I can do, and that's the x plus 1s. And so from here we're going to just multiply across the top and bottom. So we have x minus 3 times x plus 5 all over x minus 2 times x plus 2.